Hello, good afternoon to one and all. My name is Uday. Today I am going to teach you about quantum AI. Before going to discuss about quantum AI, I want to, before that, what is there? Before that, we have classical AI. I will tell you each and everything, no need to worry right now. Before that, I am going to tell you about classical AI. It's not a old AI, it's not a generative AI, it's a traditional AI. Okay, it's a traditional AI. I will tell you at the last. Okay, no need to worry at all. See, imagine a password cracking, a password cracking, otherwise drug discovery, otherwise a route optimization. Route optimization it means in Google Maps or somewhere, right? Route optimization. Okay. What these classical computers will do, old traditional AI, what it will do means it will try one solution only at a time. Try one solution at a time. Try one solution at a time. This is the problem of classical AI. That means traditional AI. Only one solution only at a time it will try. Okay. Because of that, what is the problem? Very slow for huge problems. Very slow for huge problems. That's the problem of classical computers. Okay. Then that's why we go for quantum computing. Okay, I will tell you about quantum computing everything. Today I'm going to teach you about quantum AI. Quantum computing is different and quantum AI is different. I will tell you at the okay. Quantum AI means it uses quantum computing quantum computing plus AI. Quantum computing plus AI it uses in quantum AI. Here, instead of 0 or 1, okay, 0 or 1, qubit, qubit that is equal to 0 plus 1 at same time, okay, 0 plus 1, that means multiple solutions it is going to give you, okay. For example, in classical AI, that means for traditional AI, search 1 million records means if you want to search 1 million records, if you want to search 1 million records, one by one, how much time it will take? In traditional AI, if you want to search 1 million records, how much time it will take? One by one record it if you want to search. That's the drawback of traditional AI. That's why they are going for quantum AI, quantum computing. Okay. Here it takes many possibilities at once. Many possibilities at once. Okay. In classical computing, either 0 or 1 only it will try. Only one solution only, either 0 or 1. But in quantum AI, 0 plus 1 at the same time. That means it checks many possibilities at a time, at once, at once. Okay, that is the advantage of quantum computing. That's why here by using quantum computing, I am using quantum AI. Okay, here Google is an example. Quantum supremacy experiment. Quantum supremacy experiment was done by Google. Okay, experiment. Next, pharma, pharma. So they're not pharma organizations. Drug molecule, drug molecule simulation. Drug molecule simulation was done by pharma companies. Okay, finance. Risk optimization will be there. Risk optimization will be there. Okay. Next, cyber security. In cyber security field where we used okay cryptography. Okay. Like this, in different areas we used this quantum AI. Okay. In Google for quantum supremacy experiment. In pharma industry, drug molecule simulation. In finance, risk optimization. In cyber security for cryptography. Okay. In data processing, if you want to process the data in traditional AI, it is sequential. It is sequential. But in quantum AI, it is parallel. Okay, because of superposition. Because of superposition in quantum AI, in quantum computing. Okay. Next, speed wise, in traditional AI, slower. But in quantum AI, exponential. Exponential speed. That means for some problems. For some problems. Next, optimization wise. Optimization is traditionally hard, but quantum is easier. Okay. Simulation wise also limited in traditional AI, but very powerful in quantum computing. Okay, very powerful. Okay, data processing wise, traditional AI is sequential, but parallel in quantum AI. Speed wise slower in traditional AI, but in quantum exponential. Optimization wise hard in traditional AI, but it is easier in quantum. Simulation wise limited, it has limited features in traditional AI, but is very powerful in quantum AI. Okay, next I want to tell you a few more things also. Because before going to discuss anything, what is meant by classical AI? See, classical AI is nothing but old AI is nothing but based on the rules. So that means if or else conditions. Classical AI is nothing but learning phase. Okay, learning. Generative is nothing but Gen AI is nothing but creating. Okay, in simple, I am saying, classical AI is nothing but learning. What learning? It's like a normal AI, machine learning. That's the traditional AI also. Okay, Gen AI is the advanced AI, creates content. Old AI means rule based, no machine learning, no learning rules. Okay, see, in old AI, fixed rules will be there. Okay, but in classical AI, it learns from past data. Due to it is learning, it learns from past data. It predicts whether it is approved or not, loan is approved or not, loan is rejected or not, everything. Okay, see, old AI, in old AI, fixed rules will be there. I already explained in agent AI demo class. Fixed rules will be there, not flexible, but in classical AI, that means traditional AI, old AI is different, traditional AI is different. I explained everything in agentic AI video. Go through that video, demo video. Learn from past data. Okay, and predicts. Learn from past data and predicts. Because of that, it is using machine learning and predicts loan approved or not, rejected or not, like that, and predicts approved or rejected, approve or reject. Okay, Gen A is different. Okay, Gen A advanced A is just used to create content. Okay, Gen A can explain loan decision, explain loan decision. Okay, start with the user, and generate reports. Okay, this see, Chennai is used for creating the content. Okay, next, I want to tell you a few more things. Classical AI means machine learning that is using. Okay, it is learning thing. Okay, next, see, old AI means fixed rules. How old AI will look like? Fixed rules. That means rule based, fixed rules, fixed rules. That means, for example, if salary greater than 50,000, approve loan, else reject. This is the old AI. Old AI. Okay. Generative AI means, Gen AI means it is different. Okay. What it does, it creates new content generation, image generation. In yesterday's demo video, I explained those things. Okay. Go through the demo video. Okay. Example, chatbots. Okay, image generation, code generation, these are all things on the examples of what? Gen AI. Okay, next tools like ChatGPT, ChatGPT and DALL-E for image generation, DALL-E, DALL-E. Okay, next for classical AI, that is the traditional AI. In classical AI is nothing but what it does takes past data, right? It learns from past data. It does prediction based on the past data. It is going to predict the prediction, classification, okay, and then decision making. Prediction, classification, and then decision making. Examples, okay, spam detection, email related, spam detection, okay, loan approval, prediction, classification, decision making, okay, fraud detection, fraud detection. These are all the examples of classical AI, that means traditional AI. Okay, old AI means rule based, generative AI means creative content, and then classical AI means it's learning the data from the past data. It learns from past data and predict the and make predictions and classifying and the decision making. Okay, next tools like scikit-learn, tools like scikit-learn it is using, and then a regression, logistic regression, decision trees, those are all it used, those are all it is using. Okay, these are the differences between classical AI, okay, old AI and traditional AI. See, next today you built first AI mode. I want to show you first AI mode. See, next I want to tell you few more things also. No need to worry, I will show you. See, if I have to install Python, classical AI using Python code I am going to show you. Okay, classical AI is equal to what? Classical AI is equal to what? Using algorithms, machine learning algorithms, using algorithms, okay, algorithms plus data to make decisions, data to make decisions using algorithms plus data to make decisions. Okay, built using Python, built using Python. Okay, algorithm plus data to make past data to make decisions. Okay, okay, libraries like, what are the libraries I am using here? Python. Libraries like NumPy, Pandas, scikit-learn, scikit-learn for machine learning, scikit-learn. Okay, using algorithm plus data to make decisions. Okay, see, example what? Spam email detection, loan approval, face recognition, okay, face recognition, movie recommendation, loan approval. These are all the examples of, okay, classical AI. Okay, fixed rule. See, normal programming it learns from data. Okay, pattern if else logic means normal programmers classical AI. See, in normal programming fixed rules will be their old AI. But in traditional AI, it learns from data. If else logic there. Here, pattern recognition will be there. There's static. It improves with data here. Okay. Here, pattern recognition will be there. Pattern recognition will be there. Okay. Instead of if else logic. If else logic. Okay. Next step. Here, then you need to install Python. Pip space install space. I want to show you. Pip space install space numpy space panda scikit-learn. You have to use here. Okay, I already installed. That's why it shows successfully installed. Okay, next step. Next, I want to show you classical AI. See, this is the code I want to show you. Loan approved or not. For that, I am writing this code. See, loan approved or not. For that, I am writing code. Data set is simple. 20,000 means credit score 600 means 20,000 credit score 600 means loan 0. 15,000 means okay loan 1. Loan 1 here 0 here 1. 1 means approved, 0 means rejected. This is the data set. Okay, for that data set I am running the code. See here what I am doing, I am taking numpy array. I am importing the library numpy used for arrays data handling. Okay, next classification purpose I am using scale and scikit-learn. I am using machine learning library I am using. Okay, for AI algorithm for classification purpose. For classification purpose, logistic regression importing. Next, what I am doing, AI algorithm I am taking for classification here. Okay. Next, what I am doing, input features I am taking salary versus credit score. 20,000 is the salary and 600 is the credit score. Next, what I am doing, output labels. 0 means reject, 1 means what approved. Okay, next creating an AI model. Here AI model I am using. Okay, AI model I am using. Which model? I am importing logistic regression. A logistic regression model I am using. And then model, see here I am training the model. I am fitting the model. Okay, training the model. That means model learns patterns from data. Model learns patterns from data. Next, model learns patterns from data. Next, predicts new data. New data I am going to predict. Okay, based on that, when new data I am going to predict. Based on this data, new data I am going to predict whether loan approved or not. Whether loan approved or not, we will see whether loan approved or not. We will run this code. Go down. See, loan rejected. Why loan is rejected? That we will see. Okay, why loan is rejected? Data is we are modeling the data, and then we are data to model to training, and then prediction and output. See, model learns high salary plus good credit is equal to approve, low salary plus low credit is equal to reject. This is how AI will think. See, this is the low salary, this is the high one, so it is rejected. If you change to high salary 50,000, then high salary high credit score, then it is approved. See, it is going to approved. Wait, see, loan approved. High salary high credit approved, low salary low credit reject. This is how AI will think. Okay, adds more data for better prediction. 1,000 records more accurate. 10 records means less accurate will be there. Okay, see, 25,620 if you give 25,000 instead of, now it will reject low salary high credit. Okay, and then reject. Both should be high. Like that AI will think. See, loan rejected. Wait, it will come. Loan rejected, both should be high, then only it will come. Okay, next, see, companies uses classical AI for bank fraud detection, movie recommendation. Okay, e-commerce recommendation, medical diagnosis. Okay, these all things classical. See, movie recommendation. Okay, e-commerce recommendation, fraud detection, face recognition. See, classical AI runs on normal computers, but quantum AI runs on uses quantum computers. Quantum is different, right? Quantum computers are different. Okay. Next, today you are building your first AI model, classical AI model. Okay. Next I want to tell you some more things also. Okay. We will go for. I want to tell you about few more things. What is quantum computing? Those things. See, quantum computing means cryptography. See, where we used quantum computing, I'm telling quantum computing also here. Okay, few of the things I want to tell you. See, quantum computing means cryptography, for cryptography, for cryptographic keys. Okay, we used in real time, and secure passwords we used, and gaming randomness we used. Okay, cryptography, gaming randomness we used. Okay, classical, okay, pseudo random, okay, quantum, classical AI for pseudo random, quantum AI for true randomness, okay. Okay, see, I am showing the code, but I didn't explain because it's quantum computing is another course. Okay, but I am using that quantum computing for AI. That's why I am telling quantum. I am showing quantum computing code also. Okay, see what I am doing here. Here, Qiskit. Okay, this library you have to input. Okay, this library you have to input. See, pip space install space, this you have to install. I already installed in my system. Qiskit. Okay, there I am creating the circuit, add gates, and then measure, and then set up the simulator. Okay, transparent run. See, these things I am see, these things I am writing those things. Okay, in real time you no need to write. Its writing is good, but no need to write. It's your wish. Okay, and then get the results. Okay, instead of execute I am using transpile here. Okay, and then getting the results. Here what I am doing, I am creating the qubit, and apply hammered, okay. Hammered means zeros and ones, okay, and measure the random result, see, I will run this code. Wait, what is the output that you are going to get? Say random bit 1 you are going to get. Why random bit 1 you are going to get here? Because of because of why we are going to get random bit 1? Because because why are you getting random bit 1 means, see, I'm ready. It works because of quantum principle called superposition. Okay. See here, what here? Qubit QC dot history of this. That means Hadamard gate. Hadamard gate. Okay. That is, where is that one? This is nothing but a gates. Okay, and gates creates open. This is the magic step. Your cubic starts at 0. The Hadamard gate puts into a state where it both 0 and 1 at the same time with a 50-50 chances for either QC dot measure. Your cubic gate cannot stay in superposition once you locate it. Measure forces the cubic gate to choose a side collapsing into either definition 0 or 1. Okay, this is how. Okay, no need to these things. See, those are all the cubic add gates. Okay, what is the random bit? You are going to get output as 1. Okay, in quantum computing so many things are there. I need to explain you before those things. Before you understand this output, I want to explain those things, but right now I am not teaching about quantum computing course. It's separate course. Okay, I will make a demo. I will make a demo video for quantum computing, and I will show you. Here I am just showing. Okay, so many things I need to explain. Next time, random bit 0 is coming. Okay. And why it is coming like that, I will tell you in quantum computing course. Okay. The fees for quantum computing is 80,000. Okay. I can tell you. Okay. If everything I will tell you right now, it's just I'm showing you. Okay. Next, this is for optimal. First one, previous program is used for what? Random number generation. Randomly number is going to generate 0 or 1. Now it is optimization problem, route selection. See, optimization problem route selection means, see, delivery routes. Amazon Swiggy is there now. Which route is in error? Okay, like that they are going to search, and then they are for that route they are going. Okay, that is nothing but a random selection. That is nothing but a random selection. Okay, previous, that is nothing but a random selection. Okay, which route is in error, and traffic optimization. Google Maps they are using for that one, and then logistics they are taking. Okay, see, I will run this code. Which route is in error? It will show you. 10, 79, 01, 00, 011. What these are all? See, what these are all means, valid combinations will appear. See, 00211, how many are there? 00011011, 4 combinations are there. Okay, it helps reduce such space it is going to reduce. That is nothing but a optimization. That is nothing but what? Optimization problem. That means route selection. Okay, next, quantum search. See, database searching and how we are searching in quantum computing, that I will show you. See, quantum search. Quantum search means here we are searching the database, password cracking, AA search problems. Okay, based on the Grover's algorithm, it is going to work. This is the code for that one. Okay, see, I will show you. Result. See, such result. State level 11 should have 100% probability. Okay, like this, it is going to search the database and then password cracking and then a such problems. Okay, it creates all possibilities, mark correct answer and amplify probability. It is faster than the classical AI. Okay, all possibility it is going to create and mark correct answer and then amplify. This is the probability, faster than the classical search. Okay, next, if you want quantum computing, then you have to pay 80,000 fees. Okay, next, quantum coin toss. See, quantum coin toss means decision systems. Okay, how the decision systems will be there in quantum computing, that we will see. AI decision making, simulations, game logic, for game logic purpose. See, you head or tail, like that. Okay, see, coin is equal to 0, head, tail, that I will see. That I will run and I will show you. See, tails we are getting. Tails we are getting. That means, based on the, see, based on the AI decision making, based on the simulation game logic, toss will have quantum coin toss. Decision systems will decide whether it is a head or tail. Okay, next, next, next I want to show you quantum entanglement secure. That means for secure communication means cryptography, secure banking, security. In these areas we are using these codes. Okay, quantum entanglement, secure communication wise, security purpose, banking security, they are using this thing. For entangle, this is 1152300477, like that. Okay, see, what means both qubits are always same. It used for secure transfer data. Qubits means 0 plus 1. Okay, secure for data transfer. Okay, see, randomness means these are the programs that I want to show you in quantum computing. Okay, no need to worry at all. If you are interested, if you joined in quantum computing in my session, I will tell you so many things in quantum computing. Okay, just I want to show you quantum computing, how the code will be. Okay, next, what is the, see, in classical, that means in traditional AI, randomness is the problem. Randomness, okay, is fake in classical AI, but in true in quantum AI. Search-wise, slow in slow in classical AI, traditional AI, fast in random AI. Okay, quantum AI, optimization. These are the problems. Okay, hard in classical AI, efficient in quantum. Next, security wise breakable in hard, but hard in quantum AI, high security in quantum AI. So okay, this is a simulation. Real quantum computers exist in the cloud. Okay, IBM Quantum. Okay, this is just a simulation, just a simulation. Okay, real quantum computers exists in cloud. For example, IBM Quantum. For example, IBM Quantum. Okay. See, quantum is best used for huge combinations, complex optimization, security systems, secure system to secure the systems, not for simple applications like calculator, CRUD applications, create, read, update, delete, not for that applications. Okay, for secure applications, especially for banking securities. Okay, complex optimizations in that case, we use these things. Okay, what we discussed just now, quantum computing examples we discussed. Okay, in quantum computing is nothing but an engine. Quantum AI, quantum computing is nothing but engine. Quantum AI is nothing but what? Quantum AI is nothing but application. Uses quantum computing. Okay, loan approval. See, loan approval based on fixed rules in traditional AI, but in quantum AI, it evaluates multiple risk scenarios simultaneously. Better optimization in complex spaces. That's why we are using quantum computing in quantum AI. Okay, it evaluates multiple risks scenarios simultaneously, parallelly. Okay, every quantum AI system needs quantum computing. Okay, but every quantum computing can exist without AI. See, quantum AI needs quantum computing, but quantum computing don't need AI. Okay. Next, quantum computing is a technology. Quantum AI is quantum computing is nothing but a technology. Quantum AI uses that quantum computing technology to build intelligent systems. Build intelligent systems. Okay. Now you understand, right? What is the difference between quantum computing and quantum AI? Okay. Next, I want to show you. Next, I want to show you one more things. Okay. Next, I want to show you about one more practical. Okay. See, next time I want to tell you one more thing also. Quantum computing means quantum computing is nothing but a type of computer. Quantum computing is nothing but a type of computer. Uses qubits, 0 plus 1. Okay, superposition. Okay, entanglement. I already show you examples also, right? Entanglement. Okay, focus on how to compute this everything will be done in quantum computing, but quantum AI, it uses quantum computing technology, okay, to improve AI models, to improve AI models. See, it focus on how to make smarter decisions, by using quantum technology. Okay, how to make smarter decisions. But quantum computing focus on how to compute. But here, how to make smarter decisions. Quantum computing is nothing but a calculator. Suppose if quantum computing is nothing but a calculator, quantum AI is nothing but a smart assistance using that calculator. Okay, if quantum computing is nothing but a calculator means quantum AI is nothing but a smart assistance using that calculator. Without calculator, assistant cannot compute, right? Without quantum technology, quantum AI won't work. Okay, but without quantum AI, quantum technology will work because it focuses on computing. But in quantum AI, it focuses on how to make smarter decisions. Okay, these are the advantages. And see, type-wise, quantum computing is technology, but quantum AI is application. Goal-wise, solve complex computations, but here quantum AI is build intelligent systems. Okay, next focus on computing, that means physics plus computation. AI plus optimization, quantum AI is focusing. Example, Shor's algorithm. Here is quantum ML model. Dependency is independent, it depends on quantum computing. Okay, these are the differences between quantum. See, quantum computing means I will show you quantum computing. Quantum shortcut I am writing. Don't why sir is writing spelling mistakes. Don't think like that, okay? Because of time constraint, so build a circuit using Qiskit. Okay, it is a library Qiskit. Apply gates. Okay, h comma x. Okay, c comma cx. I will tell you in quantum computing course what is this all things. Get probability outputs. Get probability outputs. Okay, no intelligence, just computation. No intelligence here in quantum computing. Just computation. Physics plus computation, logic computation, calculation. Okay, next just computation. But in quantum AI, it uses quantum technology, right? It uses quantum circuit. It uses the circuit combined with AI logic, combined with uses circuit and combined with AI logic. AI logic in the sense, machine learning algorithms, it is going to combine classification, okay, prediction, decision making, okay, prediction, decision making, okay. Example, fraud detection, drug discovery, okay, financial risk prediction, those are all things. Quantum computing do parallel computation. Probability based outputs, complex math applications faster. See, in quantum computing, parallel computation it is going to do, and also probability based outputs it is going to get zeros and ones. Okay, that means approved or rejected like that. Complex math application faster it will do. But in quantum AI, pattern recognition, optimization, learning data from past, that means learning models. Okay, those are all things comes under, okay, comes under quantum AI. Okay, these are the differences between quantum computing and quantum AI. Why I am telling each and everything means, in later stage you no need to confuse the things. Okay, everything you need to understand. That's why I am saying these are all things. Okay, next I want to show you one more example also. See, this also I want, this I will show you later. Next I want to show you one more example. So what is this, sir? Means qubits plus qubits. Qubit 0 is in superposition. Qubit 1 is flipped to 1 fixed condition. Randomness, 2 randomness. Okay. Qubit plus entanglement I am showing. Okay. Entanglement is coin header toss. See, I want to run this code. See, decision is medium risk it is getting. And I'm writing the code 01, say medium risk it is getting. If you want high risk, then you can remove this thing, you can save it, and then you can run this one, then you are getting high risk, right? High risk, see, low risk you are getting, low risk you are getting. If you want to remove this thing also, then you will see low risk only. Okay, we will see. Unknown state. Okay, unknown state. Okay, next I want to run this code. Unknown state like that. Okay, high risk, medium risk, low risk, unknown state. Okay, these are all the things you will get. What here, qubit plus entanglement it is going to do, and then it is going to will take the decision as high risk or low risk or anything. Here what we are doing, we are just importing the quantum tools I am importing, and then 2 qubits I am taking. 2 qubits, q2 comma 2 means here 2 qubits, q0 and q1, q0 and q1, two classical bits. Okay, output storage. Qc of h means q0, q0 becomes 50% 0, 50% 1 like that. Okay, then qc of cx of 0 1 means q of 0 means 1, q of 0 is equal to 0 means nothing, 1 means flip q1. Okay, result q becomes entangled. Okay, see here one is Q0, one is Q1. Okay, 50% 0 and 50% 1. Okay, and then Q01 means flip Q1, Q00 means do nothing. Like that we are writing, and qubit becomes entangled here. Once entangled, it measures both qubits. Okay, it measures both qubits. Then it is going to give the outputs. Okay, it creates two qubits, apply superposition, entangle them, measure them, and observe linked outputs. That is happening here. Okay, that is happening here. Next, next I want to show you one more thing also. See, this thing also I want to show you. See what is output you will see. This is the entangled output. Okay, no need to worry this thing also. QI1 also no need to worry. And then next low risk, high risk, medium risk, we will see. See this thing, this thing also we need to check. What is the output for this one? Loan approve. See, this is also entangled one. No need to worry. Next, this is the approved loan or not. This also we need to check. See, approved loan. When it is going to reject. See, when it is going to reject means if you remove this one, if you remove this one, then we will see. Okay, unexpected event. Okay, we will see. Where it's text. Okay, no need, no need. Oh, okay, I understand. Okay. Now we will run. Approved loan. Okay, approved loan like this. Next, what we need to do? See, these are all the things we are using for quantum AI. Okay, see QC.ht of 0 means QC dot previous code QC dot h of 0 means random input like a uncertainty. QC dot x of 1 means set condition to 1 like user data. QC dot cx of 0 comma 1 means it applies rule if random is equal to 1 change outcome like that. Okay, based on that it is going to take the a is going to take whether it is high risk or low risk or any data. Where we are using this thing in banking system for customer data risk factors, quantum helps these all things. Okay, next I want to show you one more thing also. Okay, next I want to show you one more thing also. See, in quantum AI you need to understand multiple qubits, learn quantum gates, entanglements, these all things. What is a qubit? Qubit means 0 plus 1, multiple possibilities it is going to check. Hadamard means h means hadamard, create superposition. Okay, yesterday 1 qubit, today 2 qubits. Real AI problems needs multiple variables. 2 qubits are connected. If one changes, other also changes. Two coins always show same result even if far apart. Okay, H means superposition, X means flip 0 and 1, CX means controlled operation, entanglements. Okay, sorry for the disturbance. Okay, next I want to show you. Next I want to show you. I want to tell you about one qubit, one quantum. Next, this we will run. See, loan rejected 53.43%. Why? Low risk, high score. If both are high, then only loan will be approved. That means if I change 40,000 to 60,000, then loan approved. You will see. loan approved. What is this confidence means? I am using standard scalars there. Okay, loan approved. Okay, these are the things that are there inside. Okay, where? Tell me where? Inside quantum AI. Okay, to know quantum AI, we need quantum computing. Okay, by using quantum computing technology, we uses quantum AI. Okay, okay, for face recognition, e-commerce recommendation. Okay, so many things, in so many areas we are using pattern recognition. Okay, and see, because of quantum computing, so many advantages are there. Okay, because of quantum computing, so many advantages are there. See, it runs on quantum computers. Quantum computing cryptographic is security, mainly for securing passwords in banking. We are using two randomness. Okay, quantum computing is an engine, but quantum is an application. Okay, these are the advantages of quantum computing. Okay, quantum we uses circuit and combine classification prediction decision making. We uses quantum computing technology and combine AI logic machine learning data. Okay, here only build a circuit, apply gates, get probability outputs. Okay, these are the advantages and disadvantages and differences between quantum computing, quantum AI, and classical AI. Okay, along with practicals. Okay, in tomorrow's session, I'm going to see quantum computing. If you want, means the fees for quantum computing is 80,000 to 1 lakh. Okay, um, because it will take 130 sessions for quantum computing. I am going to teach you almost 100 sessions. Okay, see, in one session only I am telling these many things means understand. Demo session only I am telling these things, these many things means understand. In later, how many things I am going to tell you, because see, I am always concentrating mainly on, I am always focusing on, if you went to IT industry, you will get a job immediately. Not only that one, you need to survive in the industry. It's my goal, because my students need not be suffer. Okay, they will be happy while working. After getting the job also they will be happy. That's my motto. Because see, some students they learned and they didn't practice, and sometimes what happens is they know theoretical but they didn't practice. They didn't know practicals. They didn't know how many ways we need to write a code, how many ways we need to think the with the real time real IT real time practicals. These are things they don't know. Once they went to industry, they suffered a lot like anything, because sometimes they lose the job also. That's why I am mainly focusing on theoretical plus practical along with real time. Everything I am integrating and then I am showing to you. Okay, in demo session only I am showing these many practicals means understand how in daily sessions how many practicals that I want to show you, because without practicals you won't survive in the industry. Okay, that's sure, no doubt at all. That's why my students don't want to suffer to get a job, or don't want to suffer to survive in the industry. Those are my main mottos, because I started this online training mainly for the sake of students' sake. Okay, mainly for the sake of students' sake only, because there's so many people are suffering. They learned a course and they went to IT industry. They were not able to perform the, and they are not able to write the code, and they are not able to perform the things as well as, then they are suffering like anything. That's why I started online training. Okay, okay guys, no need to worry at all. I will show you everything in practical oriented only, along with theoretical plus where we used in the real time. Okay, this is my website, guys. This is my website. This is my website. Go to this website. Oh, database connection failed. Why? Internet is connected now. Okay, I will check. Database make sure MySQL is running on the database as we create your download database. Okay, this is my website. Maybe on the server side I am running some things. I think. Okay, yesterday I done updation that see these are the courses. Okay, these many courses are there. Refer to your friends also if they want. Okay, refer to your friends also. Okay, before to join course you have to sign up here. Okay, you have to give full name, email, password, confirm password, and then create account. Then login credentials will come. Go to home, or here also you can log in. No need. Inside the bank credentials will be there. Go to home. See here, quantum computing or quantum. So many courses are there. No, I am searching for quantum. Maybe I didn't upload here. I think. Okay, courses. So quantum is there or not? I didn't add this one. I think. Just now I started. Okay, I will start later. Okay, see like this, quantum like this, quantum computing and quantum AI. She said like Salesforce, quantum AI is shown, like mega BPM, quantum computing is shown, and then fees will be there, and then enroll now. See, once you enrolled, there it is asking your email ID password. How you that email ID password you are going to get here in sign up you created, right? That email ID, the once you given it is email ID password will be that you have to use here enroll now. In enroll now you are going to use that one, and then you can go inside, then banking details will be there, you can pay the fees there. Okay, in tomorrow's session if you pay the fees then only I will send the link. Okay, because demo session these many things I am explaining inside. Second section is also very important. Almost 90 seconds will be there. See, go to home, go down. This is my phone number. See, this is my mail ID, uday859@gmail.com. Okay, if you have any doubts you can call me or ping me or chat with me. Okay, I can clarify your doubts at any time. No need to worry at all. Okay. Thank you guys. Thank you very much. It was a nice meeting to all of you. If you still have any doubts, you can call me or chat with me or ping with me. I can clarify your doubts at any time. Okay. Okay guys. Bye. Thank you.